Thank you for that kind introduction. So what I'm going to talk about. Now, I don't know about you guys, but I am sick and tired of hearing this particular statement, prevention is better than cure. It's such a universal truth, though. I mean, every time I don't go to the gym, or I get caught having a smoke or have too much drink or whatever, my wife goes on about this, prevention is better than cure. Doctors say this, it's so annoying. But the fact is, it's actual absolute truth. It's one of those universal truths that we can't get away from. So that's what we've been talking about, right? We've been talking about building mission critical systems and taking various precautions or proactive measures to make sure that systems are reliable down the line. And another thing which I hijacked from Lilan's presentation, unfortunately, or fortunately, is this particular statement, right? That if something is going to go wrong, usually it goes wrong at the most critical sort of time. Now take me for example. I was perfectly healthy all this time. Today morning, I'm so excited that I'm going to stand in front of a bunch of engineers and share some thoughts with you guys, and I come down with a cold and a sore throat. Usually the case. So bear with me. Hopefully, I'll get the 15-20 minute session without an issue. But what it means is that, so what do I want to talk about? Now, the architects, the engineers talked about the technical side of things, things that you do at design stage, at architect, level, with regards to building mission critical systems. I am not going to talk about the same thing. It's already been done, right? So I'm not going to talk about more preventive measures or design stage, things that you guys need to do as software engineers or systems engineers or whatever level that you are working in with regards to building mission critical systems. I want to talk about something else. I want to talk about the fact that things go wrong, right? I mean, we kind of established during the sessions before the fact that, things are inevitably going to go wrong. I've been told, in my experience, I've seen that the modern mission critical systems are so complex in nature. There are so many moving parts, so many variables, too much dependencies on infrastructure, networks. There's so many things that can go wrong. And usually something small goes wrong and it snowballs into a big giant code red. That's been kind of my experience over the years as a systems engineer, as an implementation engineer. So everything that we talked about so far in our sessions between Lilan and Suho is about taking precautions to mitigate some of those failure scenarios or take action proactively to make sure it doesn't happen. But if you guys get it right 100% all the time, people like me will be out of a job. Because what am I going to do? I mean, if the systems are so reliable, no bugs, nothing on that end, there's no requirement for operations and systems engineers, right? Right? But fortunately for me, I'm not worried because I know from experience things are going to go wrong at some level or the other. So I'm not worried. And that's what I want to talk about. I want to talk about what can we do as engineers, what are the different practices that can be employed to think about reactive support, or when things go wrong, how do you actually recover from those scenarios faster so that your customer doesn't notice a lot of things going on. That's where we want to talk about reactive, going from reactive support to proactive, and then maybe even a little bit further into predictive support. So that's what I want to talk about, and obviously focus on a few design elements with regards to predictive and building an effective health score, which is one of the fundamental building blocks of predictive support. So before we get there, let's initially understand the reactive support part of it. This is fairly straightforward, right? I mean, I assume most of you guys are coming from development background, and you guys know that you build in a lot of things, up front in your application, your component, your application, or whatever that you're building with regards to identifying and troubleshooting, right? The basic things like logs and stats and be able to trace certain issues or whatever, maybe certain diagnostic tools that you think about upfront, or even things that you use to recreate situations, right? I mean, these are certain standard elements. But how many occasions have you come across? I have come across many where you have a particular issue, you go to the developer and say, okay, we have this issue, we need to troubleshoot. The first response is, oh, that particular information is not logged, right? That information is not there. So then you have to try and recreate that situation with the same exact conditions with the logs enabled or with another level of logs, for example. Practical situation, I understand the concept of logs and the fact that it takes, it taxes the application to write logs. But still, at an initial design stage itself, if you can focus a bit on trying to understand what critical information needs to be logged, what critical stats needs to be there for troubleshooting down the line, will save you a lot of time further in terms of mission critical systems troubleshooting. As most of the developers would know, some of your time or some of your critical time is taken up for troubleshooting and figuring out things, right? So it's important in my view to focus on this particular aspect of reactive support. What information, what mechanisms, what logs, what stats do we need to have further down the line, rather than being reactive of reactive support, be proactive about reactive support. Does that make sense? So proactively you think about what information would I need to troubleshoot issues and have that in place. Another important thing, now this depends on the support model we employ. Now certain enterprise level mission critical systems might have a DevOps sort of support system where the issues directly end up with the developers themselves. For Sysco LABS, for example, the type of product that we do for restaurant point of sale systems which are directly consumer facing, you can't have all the issues ending up with the developers. So there is multiple support layers that that sit in the front, like a support desk, like a hotline where customers call in, and so on and so forth. If you have that sort of a model, effective knowledge transfer from development design stage directly into support layers also is very important. One of the most important things here is that they are ready when a new release or a new feature comes out. They are aware of how to troubleshoot and figure out what sort of problems that might come up. So that initial investment you do to make them knowledgeable will save you a lot of headache down the line, because they'll be able to give faster responses. You need to naturally have a good ticketing case management system for reactive support, right? I mean, you have to have a hotline or whatever other mechanisms, from Jira to Zendesk to whatever other mechanisms that you have to managing and prioritizing those issues as they come along for reactive support. And also, one of the other important aspects of reactive support is ability to get a fix into production soon. This is something that Lilana also touched upon, the shorter release cycles. How can you have CI, CD, all those different concepts in place so that a fix doesn't sit in a release for months while your customers are experiencing the issue, because you are unable to deploy it because it's bundled up with a whole bunch of other features, for example. So you can't, deploy something faster. So EBFs or emergency bug fixes, having that mechanism in place, I think is very important for reactive support. How do we go from there to proactive? A few simple things that comes in. What important aspect is that real-time monitoring. So monitoring is something that, again, at design stages, that it's very important to invest time into. How do we monitor and how do we real-time monitor things? And how do we aggregate data into a central sort of a location where you can diagnose that data and you can figure out what's going on even before a customer notices things, for example. I will touch upon a few examples about proactive support later on, but the idea is that your responses, your detection of a problem and the response that you give to that problem can be done proactively before even the customer kind of reaches out to you. We'll look at the benefits of this as well. And what is predictive? As the kind of the symbol, the crystal ball suggests, hopefully it's a little more scientific than crystal ball gazing, where using the information that you have, data that you have accumulated over a long period of time, you are able to predict something before it actually becomes a problem. Does that make sense? Now, this is something that happens quite often, right? I mean, when you go to a doctor, for example, these days, you are asked to, let's say, do a full body checkup. What are you doing? You are gathering certain amount of information. And then based on that information, your doctor might predict, okay, looking at the sugar levels or your family history or whatever, they might say, okay, there's a high possibility that you're going to catch high blood sugar or whatever, 6 years down the line. So that's the kind of predictive. Can that same concept be applied to predictive to, understand problems that might happen down the line? That's kind of what predictive support paradigm is all about. We'll talk about that in detail as we go along. Why do we have to do this? So can somebody, somebody can ask, why do we have to bother? Now, this particular research was done by American Express in 2017 with regards to customer satisfaction, and their surveys found out that only 62% of customers are satisfied with the support that they get when they have a typical issue or typical outage or whatever that goes wrong. 62% of them are happy. Only 5% say whatever software support that they were getting exceeded their expectations. I want to think of this as an opportunity, guys. Think of it. There are 95% customers who can be delighted, who we can use as an, kind of like an opportunity to attract them. If we can have support in a way that, exceeds the expectations. A problem is resolved even before they actually detect it and they have a problem, for example. That is kind of exceeding the expectations, right? There's a massive opportunity there in the current, the way that, things are heading towards, because it's all a service-oriented industry that we are, working in right now. People look for the service, the speciality, not necessarily just the functionality, but can I recover from situations? Can I get the actual support that I need to, continue my business? So this is why we need to look at predictive support, in my view. And the obvious, what proactive and predictive means is that, you detect the problem faster, which enables you to give maybe a faster response, as well as communicate, problems upfront. For example, let's say in our line of business, let's say some hardware fault. We are in the business of, providing point-of-sale devices for restaurants. Somebody might argue, is it a mission-critical system? Absolutely. If you think from the restaurant owner's point of view, who wants to, put the food and, and give a very good service, he doesn't want to write manual bills and print tickets in the, kitchen and, run around. For a restaurant, obviously, payments and point of sales is a mission-critical system. So in that context, for example, let's say he's about to experience a hardware issue. Say, can happen, or typical issues like hard disk can fail and various things. So we don't have redundancies built into a point-of-sale device like multiple hard drive arrays and whatever. So naturally, if something is about to go wrong, let's say he gets a message saying, okay, there is a problem brewing up. We have already initiated a replacement device for you, and overnight it will be shipped to you or whatever. He'll be delighted, right? Instead of him having to call us and say, look, my machine is not working, whatever. So faster, effective communications, which leads to the notion of stability. This is something which Lilan touched upon as well. If you can recover from a problem without even the customer noticing it, then the notion of stability sets in, which leads to customer satisfaction. So I want to put a few examples into what we do in Cake as well, so that this will make sense. We have something called Cake Pulse. It's a very simple agent-based tool. When I say simple, the implementation of it is not simple, but the idea is simple. In each of our devices that run across the board, there is an agent running, which reports the usage stats and errors and various other things, detects it and sends it to a central place, which is something that detects the issues that proactively might, you're detecting the issues proactively. And the Pulse tool itself gives you a certain set of tools and, capabilities to take faster responses. So for example, if you detect a certain issue, there might be an already built-in workaround that you can execute through a tier 1 agent or the initial support agent without having a developer called upon to, fix that issue or whatever, right? So Pulse itself gives you the ability to do faster responses from a proactive support point of view. And we have something called Cake Reach, not fully implemented yet, but the idea is that through Reach, we are able to communicate these things effectively to the actual stakeholders. Now, for example, if something is about to go wrong, if you're an owner of a restaurant, you might get a SMS asking, hey, by the way, we detected some issue, is everything okay? Or we detected that you restarted the device a few times. Is everything okay, for example? That's the way of effectively communicating, which leads to something called customer satisfaction surveys, right? We get better survey results. And then ultimately, it might translate to better customer satisfaction or our reputation through various, social media sites or customer review sites, for example. That's the obvious of why proactive support is better than the reactive model that, we typically employ. And remember, our destination is customer delight, right? Not just satisfaction. We should not be content with just, customers being satisfied. because there's a massive opportunity to delight customers and attract more people to it. Because through predictive support, you are guaranteeing to a certain extent uninterrupted service. Even proactive means there might be certain issues that results in a interruption. But from a predictive point of view, you are even minimizing that interruption. And you can respond to change much faster. You can communicate your requirements faster. Even if you're a developer which is developing a back-end enterprise system, for example, let's say. Based on latency and throughput and various other standard parameters, let's say one fine day you get an email from your predictive support system saying, 2 months down the line, you're going to have this massive latency problem. Take action now itself. Don't you think that is going to work in your favor? Because now you have 2 months to get ready to address that latency and load problem. How do we get there is what I want to talk about in my next thing. Remember we talked about the doctor, patient, analogy? Same thing, right? You have your tests and various data that you accumulate. You do diagnostic on it. You predict what might go wrong, and then take the prescription, or you take action on it. Simple concept. And it starts with your data that you have already. The stats, the logs, the error messages, all of that, as well as, I don't know how many of you guys work with a CRM, like a customer relationship management system like Salesforce or something like that, where you accumulate a lot of data about the customer and their operations and the system operations, the issues that they have reported from the hardware purchasing date to various information that might be available in a customer relationship management system. So all that is your data. And using that data, you do the analytics part of it. You find out which data is related to what pattern. What are the different patterns that indicate a problem down the line, for example, right? Which you lead to modeling and forecasting. Simple concept again. Implementation is obviously complex, where you need to figure out what effects, what are the different correlations, what are the patterns that ultimately kind of leads to a conclusion. And then you take the prescription, which is proactive. Might be proactive workarounds. You might add a new node to your system to handle the load proactively. You might communicate those expectations to the customer and say, look, 2 weeks down the line, we're going to have this particular interruption. Be mindful of this. Don't use this particular feature. You are able to communicate that effectively, right? And the last one, which is absolutely essential, is this is a predictive support is not a destination. It's something that you have to continue to refine, right? You have to continue to refine your algorithms, continue to refine your correlations, continue to understand what more data do we need to kind of build on top of a better predictive mechanisms. Again, simple set of layers, but implementation-wise, slightly complicated, because you have to have a very good understanding of data, the relationships, and able to forecast. Where do you start? My entry point to predictive support would be having an effective health score, right? Again, a simple concept. Like this example that I've used is from a mobile app which calculates, for example, health score of you as an individual based on how many hours do you sleep, how many steps or exercise do you do, and various things. Similar concept, right? Same thing can be applied to an application as well, where we talk about based on different stats that are available to you, you try to define a health score. It might be a utility function. You might use something like, I don't know, analytical hierarchical process or analytical network process. There are certain different models that you can develop a utility function. But if you know what are the different parameters that affects the health of your application or your subsystem or the operator or whoever, whatever level that you need to calculate a health score, if you know what those parameters are, you can come up with a formula, right? And say these are the different parameters, these are the different weightages, which gives you a proactive or a predictive measure or like a building block to build your predictive support model on. And it's a concept that is catching up. It's a simple concept again, from individual health to applications to all over across the board. You develop this kind of pulse kind of a tool where you develop health score, and then you proactively use that in your customer support sphere, customer success sphere, and even enterprise support sphere. You can use that health score proactively. That's the idea. Again, a concept which I believe is simple to explain, but implementation-wise, there can be a lot of complicated situations. Right. I think we have come to the end of the 3 sessions. Now again, we talked about for about 1.5 hours, right? I know it's kind of long, but still, to develop reliable, available systems 100% with 100% availability or the ability to predictively support them or whatever is a vast subject, guys. The 3 of us talking for 1.5 hours will not give you all the information. It's not practical to expect that. Hopefully, we have planted a few seeds in you, right? Which you will take back and do your own research and build on top of it. Just like what Lilan and Suho said, you need to do your own understanding of your applications. How can these concepts and technologies can be applied to your own context, and then figure out how we can build on top of it. So I'm hoping the session that we've had planted a few seeds, and you guys will grow it further as a Sri Lankan IT community and build even more better, bigger things as we go along into the future. Thank you very much.